Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. Fiji, and I am on the last video for this specific section on Euclidean geometry, and in this paper, which is the Department of Basic Education, the November 2020 exam that they wrote, specifically the paper 2. So when we look at this is now a beautiful geometrical rider because there's absolutely no values involved in this whole question. So when I look at this question, I'm going to again ask you to do it yourself first. So hit the pause button and then you come back and make sure that you are able to do the sum. As you guys have gotten to know me through the videos, I hope that you are starting to see that before I even look at 11.1 and 11.2, I'm first going to mine. I'm going to dig into the nitty-gritty, the information, and then try and extract all that I can to make sure that I've got this covered. So when I look at this specific sum, it says there in the diagram below, PQ is a tangent to the circle. So I've got three options when I'm looking at tangents to a circle. First of all, Theorem 7, Theorem 8, and then Theorem 9. Now I look at that and I know that none of those, Theorem 7 or 8, I'm going to be able to use, because I don't have a radius for Theorem 7 and I don't have two tangents, so I can't use Theorem 8. Now, it's a little bit sad for me that we haven't been able to use Theorem 8 at all in this question paper, but please, it doesn't mean it's never going to be there. I'm specifically going to look at Theorem 9. By applying Theorem 9, I can see that Q4 is first of all equal to S, but also equal to W1, okay? Very few of my students seem to see the W1, but it's because the lines, the chords come together on the circumference by W1. Okay, I hope you see that, ladies and gents. So when I look now at the rest, I need to now start being creative. It says there that PRS is a straight line and that RW cuts SQ and QT at Q and L respectively. Now there is something indicated on the sketch that's not given in the information. That is that SRP is parallel to TLQ. Be careful that you don't miss that. When I see parallel lines, I think at F, U, and N. Now the most obvious one is that there is an N. And that N tells me that Q2 is equal to angle S. And I love to write it in on the sketch there. When we look at something that is not given at all, okay, or that is again not written down, is that SR is equal to TW. Now here comes a very, very, very important theorem, because this theorem is most often looked over by all of my grade 11s and 12 students. What does it mean if TW is equal to SR? Well, what it means is there's a theorem that says if I've got sides or chords that are equal, the angles opposite those chords in the same circle segments will be equal. So the angles opposite those chords will be equal. So Q1 is equal to Q3. That is a very important one, often overlooked, ladies and gentlemen. When I looked at this now, oh my goodness, I forgot there's another n here, okay? Another n or another z going there. That R3 is equal to L1, okay? Might be useful, might not. But what else must I not forget to look at? What is the one thing you may assume in grade 11 Euclidean geometry? Cyclic quadrilaterals. Now, I don't have theorem 5 and 6, but I do have a bow tie, and there's my bow tie. So angle R3 is equal to Q1 and 2 together. Okay, so there we've got number 6 there. Okay, for number 6. Very, very important. When we now look at actually just starting new to answer the questions now, find with reasons 3 angles equal to x. Remember, in the information, it's given that Q2 is equal to x. But then, I've got angle S, that is x. I've got angle W, that's x. And I've got Q4, that is x. In other words, I've answered the question. So let's write it down. Angle Q2 is equal to angle S, which is x, alternate angles, and PS is parallel to TQ. Remember to indicate that it's because of parallel lines that they are equal. Next up, angle S is equal to Q4 because of tan chord theorem. And because I just want to use kind of all the different theorems, I'm going to say that angle S is equal to W1 because of angles in the same segment. Okay? Guys, this is so simple and straightforward. If you apply your theorems correctly, but you apply all of them in the right order, that is important. Just go systematically, because otherwise you might forget a theorem or 5. Okay? Next question. Prove that angle R1 is equal to L3. Now, it took me a minute or two. To look for how to get R1 equal to L3. So what I love to ask myself is, what do I know about R1? Isn't there something linked to 11.1 where I can maybe find something about R1? So I went towards exterior angles of a triangle, because R1 is equal to S plus Q3. Again, I love that because I know something about Q3 and I know something about S. This means that R1 is X plus Q3. I love to put it in so that I know I've got the X sorted. It's now just a Q3. What do I know about Q3? Well, Q3 is equal to Q1. Why is that again? Because angles opposite equal chords. Now look at this magic, ladies and gents. I now start on the right-hand side. What do I know about L3 in this little triangle there? The same thing I did with R1 is that L3 is the exterior angle of that red triangle. So in other words, L3 is W1 plus Q1. But W1 is X. So actually L3 is Q1 plus X. Now let's compare these two statements with each other. The X's are the same. The Q3 is the same as Q1. So what must happen? If the right-hand sides are equal, then also the left-hand sides must be equal. So L3 must be equal to R1. Wow! This is a mental arithmetic gymnastics course we are going through today. Ladies and gents, this is not easy maths, but it is not impossible. So what I need you to do is to get that mind working and always look at, but what did I do in 11.1? How does it help me in 11.2? And let's do that exact same thing now with 11.2.2. It says here, prove that PRKQ is a cyclic quadrilateral. So I ask myself, how do I prove something to be a cyclic quadrilateral? I have that to be equal or to a cyclic quad. So I've got three options. Theorem 4's converse, which says that angle must be that angle. I've got theorem 5's converse, which says that plus that must give me 180. Or I've got theorem 6's converse, which says the exterior angle must be equal to the interior opposite angle. Now, I'm not going to work with theorem 4 and 5 because for theorem 4 there is no bow tie because K and P is not connected. Okay? Also, I'm not going to work with 180 degrees, theorem 5's converse, because I've got no values. Maybe if there were 90s involved, I would have gone, okay, maybe, yeah, just, let's go for it. But I don't have. So what I'm going to look at is theorem 6. So I love to write this for the examiner. What do I need to prove? That R3 must be equal to Q3 and 4. So I write it as my RTP, ready to be proven, that R3 must be equal to Q3 and Q4. So how do I do this now? Well, I look at my RTP statement and I think, what do I know about R3? I know that R3 is Q1 and Q2, okay, because of angles in the same segment. What do I know about Q2? Well, that is X. But wait, isn't Q4 also X? Oh my goodness, already Q2 and Q4 is the same. Also, Q1 and Q3 is the same. We've already proven it. So in a nutshell, ladies and gents, we actually have proven left-hand side equal to right-hand side already. So let's write it down. Let's start with what we know about R3. R3 is equal to Q1 plus Q2 because of angles in the same segment. Okay? When I've done that, I now go and say, but Q1 is equal to Q3. We've proven it. Also, Q2 is equal to Q4. It's X because we've already proven that in 11.1. So therefore, let's finish this off. Angle R3 must be equal to Q3 plus Q4. And this leads me towards saying, therefore, PRKQ is a cyclic quad. And why is this? Because the exterior angle is equal to the interior opposite angle. Okay? And there, ladies and gentlemen, we have proven this absolutely amazing sum. So as a tip going forward, please know, grade 11s, Euclidean geometry, there's going to be most of the exams, two types of questions. Number one, ones with values in it. Those are usually the easy ones, 30s and 20 degrees and 5 centimeters. But then there's also riders, which rely on logical deduction. If A is equal to B and B is equal to C, then A must also be equal to C. The secret to success is mining first of all. So starting with your information, regardless of where this is going, start with your information. Then, when you're looking at your answers, after you've gone through all the theorems, and you look at the questions you ask, it's looking at the monkey behind the mountain. The monkey being proving this is a cyclic quad. Now the mountains are what's standing in your way to get there. Well, I need to prove R3 to be Q3 and Q4, so there's 3 mountains. And now I say, but what do I know about R3? That is Q1 and Q2. What do I know about Q1? Well, that's Q3. There's 1 mountain sorted, 1 obstacle crossed. And then Q2 is Q4, another obstacle crossed. Man, geometry is actually not that bad. For grade 12, you have to have mastered grade 11 geometry, because all of grade 12 geometry is going to build on top of this. Actually, I'm going to correct myself. Theorem 2, which has to do with similarities, we are going to build on top of grade 11 Euclidean geometry. Theorem 1, which is about the sides of triangles, that's going to be a lot of times on its own. Not always, but a lot of times. So you have to make sure that you've got Euclidean geometry covered before you get to grade 12. Wow! Thank you for listening and observing and, working through this with me. I hope it helps you, ladies and gentlemen. Your future is now in your hands. So give it all you've got the rest of this year. Make sure you get to the marks that you are due and you are capable of. So have a gorgeous, amazing, and wonderful rest of your day. Keep well. Cheers.